Hey gang, so we're going to continue with finding the area under the curve. Earlier we did rectangles, and then we did one where you had a curve and you made a triangle and a rectangle out of it. So we're going to take this one. We're going to find the diagram shows the region below the graph of the function along with some pieces of the graph, and we're going to find the area of the shaded region. Okay, estimate the area. Oh, I'm sorry, y'all, my cat has been up here with me. Estimate the area under the shade region. So what we're going to do, I'm going to make a geometric shape, and it is known as a trapezoid. Now, as I come down, notice that it's over 1.8 and up 2.8, so I need to be over, I'm hoping, I'm going to do a dash line. I need to be just right in front of the 2. Hey, I did it. This one is over 3.5 and up 1.6, so I need to, hopefully I'll land right in the middle, pretty close. This one is 5.9, so I should be on the left-hand side, and then there. Okay, and I'm going to connect the dots. Ooh, that one was really close. Okay, and what I'm going to do is I'm going to add up the trapezoids, and hopefully I'll get the area under the curve. Now, when you look at this, you're like, well, Ms. Dean, you didn't even get that area. And then you were a little bit under here, so you didn't get either one of those. And then look at here, you're way above. The idea would be that hopefully what this area is here, this little piece and this little piece, what I'm missing there, like going above and beyond, like maybe that would compensate for what I'm missing. It's not going to be accurate. And what IB is going to ask you to do is the percentage of error. Like they're going to give you the exact area, and you have to figure out the trapezoid and then tell what the percentage of error is. What's your error that you did? That's real life math right there. Applications. Okay, trapezoid. Let's talk about it. I'm going to draw this trapezoid here. Two sides on the one I have, and then this one's a little bit taller, and it goes like that. Okay, you know a trapezoid as base 1 plus base 2 multiplied by the height divided in half. That's the area of it. Let's put it equals area. Area of a trapezoid. But the question is, when you look at this, which way does it go? Think about it, and when I drew it, it's a little easier to see if you look at it like this. Oh, if I were to do the height, would we say the height? Normally it would look something like this. It would come down from that corner, and we would say that's a right angle, and this would be the height. And we would say this is base 1, and this is base 2. What I'm going to do to make it a little easier is I'm going to call base 1 A, and I'm going to call base 2 B. So instead of B1 plus B2, I'm just going to say A plus B. I think that'll be a little bit easier. All right, I'm going to turn it this way. Do you see the bases? Do you see the height? A, B, and the height? If you were to pick this up and put it on top, it's just this width right here. This is H. H is going to be a piece of cake to find. A and B are going to be a piece of cake to find because you already know how tall they are on the y-axis. You can already see it. And what we're going to need to do, we're going to label this number 1, number 2, number 3, and number 4. And I need to find the area of each of those trapezoids and then add them all together. So let's take trapezoid 1. Trapezoid 1, we need to take, I'm going to actually mark these off to A and B. So let's take A right here. How tall is A? Well, you've got an ordered pair right there, 0, 2.4. Oh, you know something? I didn't address this. I remember this is the second time I made this video. On this picture right here, they give you all the points. They give you this table as well, and I guess what they really wanted to do was you to take these and put them on here, but since they're already there, I mean, I'm not going to use that table. It's the same table. So I could kind of use it as my endpoints, I guess. So the height of this one is 0, 2.4. So I'm going to say 2.4 plus, and I'm going to take the height of this one, which is the y, which is 2.8. And I'm going to multiply it by the height, which is this right here, 0 to 1.8. So I would take 1.8 minus 0, 1.8 minus 0. And I'm just doing that because we're going to follow that pattern. I can see that it's 1.8, and you can put 1.8, but there's a pattern there, over 2. Okay, I'm going to leave that there. If you want to go ahead and work it, you can. I'm going to go ahead and keep going here. I'm going to go back and work those. Okay, now I'm going to do trapezoid 2. The height here is 2.8 plus the height here, 1.6, times the height, the width here. The height, I'm saying height, but really it's the side. I'll say the side. That maybe will be easier. The side, and this is the height right here. So the height here, we go out 3.5 from 0, but that's not how long that is. It's only this long. So if I take 3.5 and subtract off 1.8, hence is what kind of did right here. So if I take 3.5 and subtract off this little piece here, what's left is this. So 3.5 minus 1.8 divided by 2. And again, I'm going to leave that there. I'll come back and give you those numbers. Trapezoid 3, we're going to do the height here is 1.6 plus 1, I keep saying height, y'all. The side length is 1.3. How long is it? Well, it's 5.9 long. But what do we need to subtract off? We need to subtract off all of this. So we need to subtract off 3.5. Divided by 2. Let's see if I can say this last one right. Okay. The height, the side. The side here is 1.3. Plus the side here is 2.1. How long is it? Well, it goes from 7, but we need to subtract off 5.9. I was just looking at my paper to make sure I had that right. It looked a little off. Okay. So, I would go ahead and finish those up. I'm going to write down the answers, okay? In my calculator, I would just plug it in and alpha y equals it and put it all in. This is what I got when I did. I'll do these in black. Okay, I got 4 point, I hope I'm labeling these right. 4.68, 3.74, 3.48, and 1.87. And I'm going to add all those together and get 13.77. So the area under that would be 13.77 square units. In IB world, we would say approximately 13.8 because we do 3 sig figs. And we would use the approximate symbol because it's not really accurate. All right, and that's how you do the trapezoidal method. You just make a trapezoid. So we're going to do the same thing here, but this time I'm going to give you the function of the curve. Okay, so let me put this here. I'm going to move. I don't know if y'all can see that or not. There's a little reindeer on my screen. Okay, so the diagram below shows parts of a graph, and it gives you that long equation. And a region bound by the graph, the y-axis and the vertical line, x equals -2 and x equals 3. Okay, got a curve. We want to find the area under it, most likely. We're going to read this and see what it says. And we've got endpoints at -2 and 3. And we've got vertical lines that they drew. They're referring to these solid ones that are the boundaries, and then they extended them up. Okay, using the 5 vertical lines of the diagram, draw 4 trapezoids that can be used to estimate the area of the shaded region. Let's see, they drew 1, 2 more. So we've got 1, 2, 3, 4 vertical lines. So here's what I'm going to need to do. I need to make some trapezoids. So I'm going to go up here, and then this would go down. I'm just going to draw it on here. Okay, so that would be trapezoid 1. I'm going to say T1. I'm going to put that point right there. You know what? The points aren't labeled on this. How in the world can you figure out what these points are? Okay, this is not going to be straight, y'all. I'm going to eyeball it. No, that's not too bad. I don't know those endpoints. Okay. Hopefully you got some good ideas. I got some trapezoids there. I got an equation. You know what? If I look at this, I might say, you know what point that is? That's probably a maximum point, a local maximum right there. Boom, it's at the very top. It's not at 1 because if you looked before I drew on it, 1 is over here. That's where 1 is. And that is not at 1. And you might look at this one, 2 is over here and 3 is over. What in the world is that? Oh, you know what that is? That's a local minimum. I know algebra 2. I know I can do this. In fact, this one, I'm hoping it might even still be, oh, it's not in my calculator. 0.1 x to the third power minus 0.2 x squared minus 0.6x plus 1.7. I'm going to double check that I put it in there right. Yeah, I did. I'm going to graph it. Oh yeah, that looks pretty good. Remember, we're going from -2 to 3. If I wanted to limit my computer or my calculator from seeing that, I could go Windows and I could say from -2 to 3. I could graph it, and then I'm only seeing that, which is more like what I should see here. It looks a little different because, you know, this only goes up to 2, so I could even go down to the y and say the maximum for the y is like 3. The minimum for the y, I can make it like -1. I mean, we're not even in the negative, and then I could graph it and maybe, oh, there we go. Does that look a little better? Yeah. So I need to find, did you have to do that? No. That was just me wanting to make it look like this. Look at your boundaries on here. Go to Windows, set your boundaries on here. Makes it a whole lot easier. Okay, so I need to find that maximum point. Second, calculate. I want a maximum. So I'm going to go all the way back over here. Okay, enter. Go on the other side. Enter, enter. Okay, I apologize. Oh, I might be able to see it up there. Nope, I can't. Okay, so there it is. I'm going to put it back up, down in a second. I can't see it, so I have to come out here to write it. So it is -0.8968. And then it gives you the y right there too. And that is 2.0051. Oh, you know what? I didn't label that right. It's that one right there. What's this one? Do I know what that one is? I'm going to change colors because I should have written that one a little first. I know that one, the x value is -2. Oh, you know what? I can find that one real easy. Second table, -2, boom, 1.3. Okay, that might have been fast. Okay, I had the equation, I had it graphed. I just want to know at -2, what is it? It's 1.3. Can I do another one like that pretty quick? Yeah. I could do 0, and I could do 3. Okay, so for 0, 1.7. So 0, 1.7, and this one right here, 3, 0.8. Okay, I could get those real quick. But the max and the min, I got to do a little bit more work. Okay, so we did the maximum. Let's go up here and do the minimum. So I'm going to go second, calculate the minimum. Here, I'm going to go over there. I just need to be on this side of it. It takes so long to get over there. Okay. There it is. Okay, it is 2.2301. So 2.2301, comma, 0.47637. 0.47637. And if you want to throw another 6 and 7 on there, you can, but I think we're good there. All right. Do you think you can do that one? All right. If you want to pause the video, you can. Your number, I'm going to go ahead and give you the total area. I'm going to come over here and say total area if you did it right, is 6.40197316. This isn't like algebra where you know it's going to be 3 or something like that. And you're like, oh, don't tell me the answer. Yeah, no, there's no way you would get that out of that. So I'm going to start doing it. I'm going to just do T1. I'm going to find the total area there. I'm going to find the total area of T2, T3, and T4. Okay, so total area of the first one. I'm just going to start writing them. I'm going to know that they're all over 2. So I'm going to do, let's see, the height of this one is 1.3. Plus, I keep saying height, y'all. I hope y'all follow what I'm saying there. It's the side of the triangle. Is 2.0051. Now I need this distance from here. Okay, we got to be careful now so that we get the right distance in there, because we want the length of here to that right there. Now remember, that's not 1, that's negative 0.8968. So what I'm going to do is I'm going to say that number right there because it's the furthest one over. So I'm going to say negative 0.8968 minus, because remember we want to subtract off, but we're subtracting off a negative 2, right? So we're taking this distance. I guess I could have done it the other way. I could have said 2 and then subtracted off this. I could have done it that way too. That might have been easier to understand. 2 minus this distance here would give me that distance. Anyway, I'm not sure which way it would be easier to look at it. Okay, over 2. I'm going to go ahead and put my answer I got was 1.82309. 0.82309. All right, and then I did 2.0051 plus 1.7. And I did 0 minus negative, I'll put a 0.8968 over 2. .476. I'm looking at my notes. Where did I get that? Oh, that one, this side. I should have put that. Oh no, that's right. I was like, wait, what? This is 3. So 3 would be 1.7 plus 0.47. I should have put this 1.7 first, y'all. I just didn't on that one. I was looking at a different one on my paper when I was doing that one. Then my final one was 0.8. I did it backwards on this one too. Plus, I did 0.8 plus 0.47637. All right, I'm going to pull that out a little bit. See that a little better? All right, so there we go. So hopefully you're putting those in your calculator and you are getting those answers. I'm going to give you mine. I got 1.66. If your answers don't match mine, double check it, but then also my math could have been wrong if I wrote something down. I know these values right here that I'm giving you right now are right. When we do them in class, we'll double check them. All right, and then you're going to add all those together. It should add up. Now I'll do that right now. I'm going to grab my calculator. I'm going to do 1.82309 plus 1.66138 plus 2.42624 plus, ooh, where am I at? 0.49126. Looks pretty close. This is more accurate because what I did here was when I found this value, I kept it on my calculator and kept working. So then I just went up and copied and pasted and said plus, plus, plus. We'll do that in class when we do it. But anyway, that was how I did it there. All right, guys, so that concludes this video. Thanks for watching. You now know how to do trapezoid area under the curve using the trapezoidal, well, sort of the trapezoid method. The next video is going to go more into that, and then the next one's going to go more into it.